viewers, welcome to my YouTube channel. Today we are going to look at Neco Chemistry Practicals 2025. So if you're a teacher, you're a student preparing for this examination, I want you to draw close. Now remember, I don't always come out so quick. I always take my time, not until I get the main information, the unique information that will enable you to succeed in your exam. I don't come out like this. So I've gotten what you truly need to excel in this examination. Now, the first thing we're going to be doing today is to look at the theoretical verification of the endpoint, theoretical determination of an endpoint, so that you will have a template to work with. As a teacher, as a student, you have a template to work with. So starting with, the materials that were asked to be supplied to students. So from there, we'll know, the expected endpoint for this year's titration. Okay. Let's look at the reagents. You were asked to measure 6.3 centimeter cube of nitric acid, which is HNO3, and you were asked to also measure 5.2 grams of sodium triisocarbonate 4, and then 2.5 grams of sodium nitrate, NaNO3. So now, between these two substances, one is a base, one is the impurity that is in the base. So the first compound, which is Na2SCO3, is the base that is used for this reaction. So the 2.5 grams of sodium nitrate that we were asked to mix with it is there as an impurity because it's not going to be involved in the titration. It's not going to be involved in the titration. Okay, so from this information, from this data that we have here, we can make a simple prediction of the endpoint, the expected endpoint. Now, the molarity of the stock solution, which we need to verify this endpoint, the molarity of HNO3 is 16 molar. 16 molar as of the stock solution. Okay, so the molarity of the stock solution of nitric acid is exactly 16 molar. So we're going to be working with it, 16 molar. Now, we were asked to measure 6.3 grams. So using the dilution equation, C1V1 is equal to C2V2. So where C1 is going to be the concentration of the stock solution, now times the volume of the stock solution, that's the volume we're asked to measure, and that's 6.3. Now equate it to what? The new concentration that we're looking for. Remember, you were asked to make it up to 1000 cm cube. So that 1000 is your V2 in this equation. So you substitute and then make C2 the subject. You have 16 times 6.3 divided by what? By 1000. So this will give us about 0.1008, which is approximately 0.1 mole per dm cube. So 0.1 mole per dm cube is the concentration of the acid, which is your Ca. Now let's go over to the base. For the base, you were asked to measure 5.5 grams of sodium carbonate and dissolve it in 1000 or 1 dm cube of the solution. Now the other compound, which is sodium nitrate, that we asked to measure 2.5 grams and mix it with the base, is not the major or the main base for this titration. It is just there as an impurity. So we are not going to add it in our calculation. Okay. So to find the molarity of the base, we simply say, use the formula N equals small m over capital M. We are conversant with this formula. Then the small m is the mass you measured, now divided by the molar mass of the base. So 5.5 divided by 106 will give us 0.052 approximately mole per dm cube. 0.052 mole per dm cube. So that is the molarity of the base. So that's our CB. That's our CB. Now, to find the volume of acid, which is VA, we need to do what? Apply the titration equation. So the titration equation will take us to the endpoint that we are looking for. So before we use the titration equation, the equation for the reaction is required. The equation for the reaction is the sodium carbonate reacting with the acid, which is HNO3. So the product will be sodium nitrate, which is NaNO3, plus carbon dioxide, then plus water. So to balance the equation, because I have 2 atoms of sodium on this side of the equation, so I need to add 2 here, and because I've added 2 here, I now need to add 2 here to balance the nitrates. Okay, so the molarity, the mole ratio of base to acid, that is NB is equal to 1, my NA is equal to 2. My NB is equal to 1, then my NA is equal to 2. So using the titration equation, CAVA over CBVB, CAV over CBVB is equal to Na, number of moles of acid over number of moles of base. So this is a popular equation, we know it. Okay, so let's substitute. So concentration of acid, we got 0.1. So times volume of acid, that is the endpoint we're looking for, divided by concentration of base, which is the 0.052 that I got, times volume of the base, which happens to be the volume of the pipette. The volume of the pipette, which is 25 cm cube, okay? So equate it to number of moles of acid used is 2. From the equation of the reaction, we saw it, then over 1, you cross multiply. So 0.1 times VA is 0.1 VA, and that's equal to 2 times 25 is 50. So we're going to have 50 times 0.052. So VA will now be 50 times 0.052 divided by 0.1. So at the end of the day, you'll be getting 26 centimeter cube. So this is the expected endpoint for this year's titration, Neco Chemistry Practicals 2025. 26 cm cube is the endpoint. So your value might be a little bit higher or lower than this, but this is the benchmark. This is the benchmark. So thanks for watching. God bless you.